Hello everyone. In this video, we'll be talking about very important problem or very interesting problem called lowest common ancestor in binary tree. So let's read the problem first. Given a binary tree with all unique values and two node values n1 and n2, the task is to find lowest common ancestor of the given two nodes. The problem says we are given a two node value, that is n1 and n2, and we want to find the lowest common ancestor of those two nodes. So let's see what's the meaning of lowest common ancestor. I have already drawn few diagrams or few binary tree in the whiteboard. So let's see. So let's see for this tree first. So what is the ancestor of 2? The ancestor of 2 is 1 and all the nodes above it. The ancestor of 3 is 1. So the lowest common ancestor is 1. Look at the output. In this, the ancestor is 2. The ancestor of 2 is 1. In this, the ancestor of 5 is 3. The ancestor of 3 is 1. So where it meets, that is 1. Here, ancestor of 3 is 2. 2's ancestor is 1. It is 2, then again 1. So what is the lowest common? 1 is also a common ancestor and 2 is also a common ancestor. But what is lowest? That is 2. Correct? So in this, our ancestor is 3 and it goes 2, it goes above 1. And for 2, it is 1. So what is the lowest common? That is 2. So I guess by here you have already got idea what is common ancestor. So let's try to analyze this problem. So let's see, we take this tree for our analysis. So what we can see, we have its left and we have its right? When something gets returned from its left, so we can know, right, कि there is one node present in its left. But at the point there is coming something from its left and right, both the side. That means there is one node, either n1 or n2 in its left, other one is in its right. Same for this one, you can see. One is coming from its left, other is coming from its right. Same for this one is coming from this, one is coming from this side. Same for this one is coming from this side, one is already here. So this is what is the meaning of lowest common ancestor, and we can use this approach to solve. So if our root is none, it will return none. If it finds something, if it finds whether it finds the n1, whether it finds the n2, it will return the same value. Otherwise, if it does not find, we'll call for its left and right. Then we'll see if something is present in its left, we'll return its left. If something is present in its right, we'll return its right. If both the things is present in its left and right, that is, there's something coming from left and there's something coming from its right, then we'll return the root node itself. So this is the overall approach for our problem. So let's see the code now. If our root is none, then we return none. If root.data equals to n1 or root.data equals to n2, if it finds either of them, then it will return the root node. Otherwise, it will call for its left and right. Then we'll check if left and right both are present, then it will return the root node. If left is only present, then it will return left. Otherwise, it will return right. So let's submit the code and see. So yeah, all our test cases passed. So you can say, let's try to analyze it once more, like the whatever we have written. I have already put the code here. Let's do the analysis in this tree. So our root is there, n1 is there, and n2 is there. We got this node first. Root is none, no. Root data equals to n1 or root net data equals to n2, no. Then it will call for its left and it will call for its right. Similarly, this will call for its left, this will call for its right. Now we are here. Root is none? No. Root of data equals to n1 and root of data equals to n2. Oh, sorry, I forgot to say. And let's say n1 equals to 4 and n2 is equals to 6. Okay. So root of data equals to n1 and root of data equals to n2. Yeah. Root of data equals to n1. So it will return. What will it return? It will return the root node. That is 4 to return. Same way. Root is none? No. No. Then it will call for its left and right. So now the root is none, so it will return none from this side, it will return none from this side. Similarly, it will return none here. So now we'll check if left and right. No. If left, yeah, something is coming from its left, so it will return its left. That is, it will return 4. Now the turn of right comes. So from this side we'll get none. From this side we'll get the value node n2 equals to 6. It will return 6. Similarly now, we got none from its left, so this is not valid. Now from its left we got none, so this is not correct. From its right we are getting something, right? So it will return its right 6. Now we got a left and right of for 1. If left and right, return root. From left also you are getting something, from right also you are getting something, so we'll return the one, that is root. So our answer is 1. So this is how our algorithm works. Thank you.